And then our next one. The only difference between this symbol and this symbol is just this little line underneath here. So this is going to be less than or equal to. That's what that little line underneath there means. It's kind of like the bottom part of an equal sign. So it's this or this. So I'm going to give you a couple examples here. So for example, 5 is less than or equal to 5 because it satisfies the or equal to part. These two things are equal, so that does work. Another example of something like this is kind of like our first one. 5 is less than or equal to 6. And this is going to be a closed dot or closed circle. So then, of course, seeing the pattern here, our last one is going to be greater than or equal to. So same rule applies here. We could have 5 is greater than or equal to 5 because it does satisfy the or equal to part. And then we also have 5 is greater than or equal to 4. And again, this is a closed dot. So let's take a look at what this means and how this is going to be graphed. So when graphing these things, we're going to start with this one. So x is less than 3. So on my graph, I'm just going to create a point. I'm going to call it 3. So, 4 would be on this side, 2 would be on this side. This would go down to 0. This would go up as far as you want to go. So on our last slide, we saw that this, because it doesn't have the line underneath it, it is an open dot. So I'm going to put an open dot at 3. And what this is saying is that x, so some range of numbers, all have to be smaller than 3. So I'm going to draw a line, and I'm going to draw it this way. And the reason why I'm drawing my line this way is because all of these numbers here are going to be smaller than 3. If I have a 2, that is smaller than 3. So if x is equal to 2, 2 is less than 3. 1 is less than 3. 0 is less than 3. Negative 1 is less than 3. But if I were to draw the line this way, it's saying that all these numbers are true. Well, then 4 is not less than 3. 4 is not less than 3. But 1 is less than 3. That is true. So therefore, I know that my line goes that way. So basically, all that we're going to do is we're going to put our boundary point here, and then we're just going to test on both sides and see which way the line goes. So same type of thing here. I'm just going to put 10 and say these are the numbers smaller. These are the numbers larger, and this should be an closed dot because it does have that line underneath it. And then I'm going to test. If I plug 9 in for A, is 9 greater than or equal to 10? Well, that'd be no. It is not greater than or equal to 10. Is 11 greater than or equal to 10? Yes, it is. So I know that this side does not work, but that this side works. So I'm going to draw my arrow that direction. So now we're going to do the same thing, but it's the opposite. We're going to take these graphs and say what this is. So I'm going to start with my boundary point. So it's at -7. This is a closed dot, so I know that I need my line underneath there. And I'm just going to test some points. So I'm going to say -6. So it's -6 that is bigger than -7. So I'm going to say that it is greater than or equal to, and go from there. So if I were to plug in that -6, it is greater than or equal to 7, or to a -7, so then you should be good to go. Same type of thing on the next one. It's going to be a 1, and I've got a open dot, so that means that I don't need this line. And it looks like all my numbers are smaller than it, so I want to say that x is going to be smaller than or less than 1. 1 is going to be bigger than it. I don't need the line because it's an open dot. Same type of thing on the next one. A -1 and an x, and I just have to decide which way the sign goes. So here, all these numbers are going to be smaller than a -1, and I do include the line because I've got a closed dot. And very last one here, I've got my x, and I've got my boundary point of -3. And then I'm saying that x should be bigger. All these numbers are bigger than the -3, so I'm going to point it towards the x, and again, it's going to be an open, because I've got an open circle, so there's no line. So open circles have no line. Closed circles say include that, make it greater than or equal to, make it less than or equal to. I'm going through this a little bit fast, so always feel free to pause the video or run it at half speed or something like that. Let's take a look at the next page here. We're actually going to start to use these and solve them. All right, so here we go with solving inequalities. So how we're going to solve these is we're basically just going to make them like equal signs and solve them just like you're solving a normal equation. So we're going to draw this line. We're just going to pretend this is an equal sign, and then we'll address the inequality at the end. So if it's an equal sign, I'm just going to do my normal solving equation stuff here. Take out 4, find that x is going to be equal to 8. So what this is telling me is where the boundary point is. So here's 8. And I don't know yet if it's going to be an open or closed dot there. But then I'm going to, make a few more numbers here just so we can kind of see. And then basically what I'm going to do is that if 8 is my boundary point, I just need to find out which side of this makes it true. So I'm going to take a number on either side of 8. So whether it's so something on this side and something on this side. So let's take 7. And if I plug 7 in, I just have to find out in the original equation, is that true? X plus 4 is greater than 12. So I'm going to plug in 7 there. Well, 7 plus 4 is 11. 11 is not greater than 12. So this side does not check out. So most likely it's going to be on the other side, but let's make sure. So on the other side here, I'm going to check the point 9. So now I'm just going to plug in 9 for my x. So I'll say 9 plus 4, is that greater than 12? 9 plus 4 is 13. That is greater than 12. That does work. This side works. So I'm going to take my arrow and I'm going to point it this direction. And then from my original equation here, I can see that this is a greater than. It does not have the line underneath it. So I do know that this is going to be an open circle, then arrow pointing this way. So let's take a look at our next one now. So exact same thing. I am just going to draw this line, pretend it's an equal sign, and solve. So I'm going to go through and I'm going to take off 6 from both sides. And also, if you've been solving these in your head, remember how our solving equations got really hard, then it was hard to do that in your head. It's a great opportunity to go back and relearn this stuff and say, hey, now's a chance for me to fix my non-understanding of solving equations, because it's pretty much the exact same thing here. So then my next step, I'm going to divide by 3 on both sides. I'll get that x is something to 2. Now, it's going to be really tempting to just drop the sign down and say that works, but I'll show you why that doesn't always work on the next one. But let's see where this is going to go. So I'm going to make my boundary point at 2. I know it's a closed circle because my original equation has that line underneath it. And then I am going to just check points. So I'm going to check things on both sides. So I'm going to check 0 because 0 just is a friendly number that's simple. And then let's also check the number 5 for no reason in particular. So I'm going to check 0 and 5. So if I plug in a 0 here for x, I'll have 12 is greater than or equal to, well, that's all just 0 here in my x term. So I've got 6. So this does seem to work on this side. I'm guessing the arrow's going to go that way. But just to be sure, I'm going to check the other side too. So now I've got 12 is greater than or equal to 3 times by 5 plus 6. 3 times 5 is 15, plus 6 is 21. 21 is definitely not smaller than or equal to 12. This side does not work. So my arrow is going to point this way, and it should be good to go. Now, you may notice that does seem to work this way, that all of my x things need to go like this. But let's see when that doesn't work. So I'm just going to solve this like normal here. Going to add 4 to both sides. I've got 16. Got a negative 2x, and I'm going to divide by my negative 2. So x is going to be equal to negative 8. So I'm going to go down and drop that on my boundary points. I've got negative 8, and my original had the line underneath it, so that's a closed circle. And then good idea is to check and make sure you've got good points here. So I'm going to go with a negative 10. That's smaller. And I'm going to go all the way up to a 0 here, just because, again, those are easy to check. So that'd be a negative 7, 6, 5, 4, 3, 2, 1, and then 0 here. So I'm going to check both of these sides here. So again, I'll use this side in purple again just to keep that side clean. So plug that into your original equation. So I'm going to plug in a 0 here. So I've got negative 2 times by 0. Well, that's just 0. So I've got a minus 4 is less than or equal to positive 12. So is minus 4 less than or equal to positive 12? Yes, it does seem to work out there. And then if I go to the other side, if I go to the negative 10 side, then I've got a negative 2 times by a negative 10 minus 4. That would be a positive 20. Minus 4 is equal to 16. 16 is less than or equal to 12. That is not true. So this side does not work. So here's what I want you to see here. It feels like so the arrow actually goes this way. We know it goes this way. But if you were to just drop down this symbol, look at that. These two things here are not the same. x is smaller than negative 8 if you were to drop down the symbol. Well, that would be this side of it, which we just said that that doesn't work. This side does work. So this is why you should be careful with that and just check your point each time and see how it goes. So let's take a look at the last three, and I'll have you try those three, and then I'll walk through the answers here in just a second. Let's see what they look like first. So here are the next three. Try these three on your own. Be sure to check your point each time and see which way your arrow should be going. All right, so here's the first one. I solved it. I got my boundary point at -2. It's going to be an open dot because there's no line in there, and then I'm just going to check sides. So I'm going to check 0 because that's always an easy number to check, and I'm going to check, I don't know, -3. So if I plug in a 0 here, that's all going to go away. 4 is less than 12. That is true. So my arrow goes this way. You don't even have to check the other side, but I like to be exacting and make sure that it's going to work. So I'm going to plug in a -3 now. So -4 and -3 equals a +12. Plus 4 is +16. That is not greater than 12, so this side does not work. I'm for sure right. My arrow should go this way. Here's the next one. Okay, so now on this next one, I've just got a fraction here. That's okay. A fraction is just a partial number. So this is a fraction. It's going to be between 1 and 0. So let's make 0 here and 1 here. So my boundary point is going to be somewhere right around here. So I'm just going to put 6/7 here. And good news, I can check numbers on each side of those. If one kind of freaks you out, feel free to try 2 as well. So let's try 2 and let's try 0. And let's see which one makes sense here. So if I plug in 0, now I'm plugging in for all my x's. So all that. So now so all this stuff will cancel down to be 0. So I'm left with 0 is less than or equal to 6. Well, that sure does seem to work. So it seems like I'm going to go this way. And I've got a closed dot there. But let's check the other side too. Let's check it with 2. So if I was to do that, I would have 10 times by 2 should be, let's see here, I was using black there, should be less than 3 times by 2 plus 6. So this would be 20. It's less than or equal to 6 plus 6, which is 12. So that is not true. This way does not work. It does point that direction there. If you solve this a different way, if you moved the 10 over, you just end up with a 0 there. Then you have to move the 6 over. Same type of solution there. You should get the exact same answer. So even if it's a fraction, it doesn't matter. A fraction is just a partial number. I can still draw a boundary point and label it from there. Let's take a look at our last one. Okay, so I've gone through here and I've solved my next one. I found my boundary point to be at -3. And it's going to be a closed dot because I've got the line underneath it. And I've got my 2 points I'm going to check. I'm going to check 0 because it tends to be easy. And I'm going to check -5s because moving through by 5 isn't too bad. So if I plug in a 0 up in my original equation for both of these things here, well, that's going to cancel. That's going to cancel. I'm going to be left with -4 is greater than or equal to +5. This side does not work. So most likely my line is going to go this way. But just in case I did bad math, I'm going to check it out on the other side. So I've got my 2 x's plugged in there. So this would be a -35 minus 4 would be a -39 on the other side. Then I've got a positive 10 and a -5 is a -50. Plus 5 would be a -45. And this one here is true. -39 is greater than -45. So my -5 is correct, meaning that this does check out. There should be my newest graph. So if you have questions about this, definitely feel free to try a few more of these, but the summary is this. The summary is just solve like it's a normal equation. Solve normally, aka like an equal sign. That'll get you your boundary point. So that gets you the boundary point. Then your second step is just test it. So test either side of the boundary point. So if it's at 4, you just check on this side and on that side and see which way works and point the arrow that way. So that's everything there. Have a good rest of your day, and I will talk to you when I talk to you next.